All right, okay, guys. The review should be pulled up. Your test tomorrow is 12, 13 questions, something like that. Anything that we have talked about in 1.5, 1.6, 1.7, you guys could possibly see. So I'm going to go over different types just to make sure that you understand. If you have a problem like this where you're dividing, okay? A lot of you guys got points off on this problem on the quiz because you didn't put it in standard form first and then your signs are messed up. If you have a question like this, you need to rewrite it as -3 plus 8i over 1 minus 5i. The real part of the number comes first, the imaginary part comes second. So now we see, okay, what is the problem here? Well, the problem is that there's an I in the denominator and it can't be. So I have to multiply the numerator and the denominator by the conjugate of the denominator. What would that be? Good, 1 plus 5i. So I'm going to simplify the denominator first. What's up? Whatever the sign is with the I is what's going to change. Good question. I'm going to simplify the denominator first just to make sure the i's cancel out. So 1 times 1 is 1. 1 times 5i is plus 5i. Negative 5i and 1 is minus 5i. Negative 5i, positive 5i is minus 25i squared. When you guys see I squared, what do? Cross it off and you change that sign in front. What happens to my positive and negative 5i? It cancels out. So what are we left with in the denominator? 1 plus 25, which is 26. So exactly what we needed to happen did. The i's canceled out. We're good to go. So now go ahead and simplify the numerator. -3 times 1 is -3. -3 times 5i is minus 15i. 8i and 1 is plus 8i. And then 8i and 5i is plus 40i squared. When you guys see I squared, what do? Cross it off and change that sign. That becomes a real number now. So combine real with real. -3 and a -40 is -43. Negative 15i and a positive 8i is minus 7i. When you get here, you should separate just to see if you can simplify or not. -43 over 26 minus 7i over 26. In this case, neither of them simplify. You might get where one fraction simplifies, one doesn't, but you have to make sure you simplify if it can. In this case, since it doesn't, you could leave it either way. You could leave it over one denominator, or you could split it up. It doesn't matter. I'll post all these answers tonight, so if you just want to watch and then go through. Okay, anytime you guys are solving, the directions are going to say to solve and check for extraneous solutions. You have to check, guys, because not all the time do solutions work. Sometimes one works, sometimes one doesn't. So you need to go back to the original to check. I'm not going to take points off if you don't, but you're going to get points off if you leave answers that don't actually work. So when you have a radical, these are our radical equations. I told you guys, isolate the radical, circle it. There's two things that you have to get rid of before you can get rid of that whole radical. There's a positive 7, and you're multiplying by a -1. So the first thing we're going to do is subtract 7 from both sides. And we have negative square root of 2x plus 3 equals 12 minus 7 is 5. That negative does not distribute inside your radical. This is times, right here, a -1. So you're going to divide both sides by -1. So you have the square root of 2x plus 3 equals, what's 5 divided by -1? -5. Good. Now that the radical is by itself, how do we get rid of it? You're going to square it. You're going to square both sides. When I square a square root, it cancels out. So you have 2x plus 3. -5 squared is how much? 25. So solve your equation. Subtract 3 from both sides. 2x equals 22. Divide by 2, and x equals what? 11. X equals 11. Now, before you tell me that you are right, you need to go back and check. Very quickly, put 11 back into the original equation. So it's 7 minus the square root of 2 times 11 plus 3. Does that equal 12? So I have 7 minus, what's 2 times 11? 22 plus 3 is 25, okay. 7 minus, what is the square root of 25?
5.
Guys, does 7 minus 5 equal 12? No. So is this an answer?
No.
So your answer here would be
No solution.
no solution. It's not x equals 11. Just because algebraically something worked out, you have to go back and check. Yeah. Extraneous. It's going to say it right here. See in the directions how it says extraneous solutions? That's when those are extra. They don't work. All right, you come up to number 5. How's 5 a little different?
Two radicals.
It's a radical equals a radical. So I don't have to worry about getting rid of anything that's being added, subtracted, multiplied, or divided to the radical. I just have to get rid of the radical itself. So what do I do to both sides? You square both sides. Good. When you square a square root, it just cancels out. So 3x minus 5 equals square root 4x minus 11. So in this case, move x's to one side and numbers to the other. I'm going to subtract 4x, and then I'm going to add 5. So 3x minus 4x is negative x. Negative 5 and 5 cancels. 4x and a negative 4x cancels. And negative 11 and 5 is a negative 6. So what does x equal? X equals 6. Now I have to take that number and plug it back in. So I have the square root of 3 times 6 minus 5. Does that equal the square root of 4 times 6 minus 11? What's 3 times 6? 18, okay, minus 5. What is 4 times 6? 24 minus 11. What's 18 minus 5? 13. What's 24 minus 11? Does the square root of 13 equal the square root of 13? Yes, so that means 6 is the solution. You're good. Everybody with me? All right. This is a different kind of an equation. This is called a rational equation. This is when we have fractions. You have 2 types of rationals, like in this case where a fraction equals a fraction, or when you have to get a common denominator. When you have just a fraction equal to a fraction, what can you do? You can cross multiply. I'm just going to take these 2 and multiply them together. So x plus 1 times x minus 5 equals x plus 3 times x minus 4. Just cross multiply, and then we're going to solve. You're going to FOIL both sides and solve for x. So on the left-hand side, x times x is x squared. X times negative 5 is negative 5x. 1 times x is x, and 1 times negative 5 is negative 5. If you combine like terms in the middle here, you have x squared minus 4x minus 5. On the right, we're going to FOIL. So x times x is x squared. X times negative 4 is negative 4x. 3 times x is 3x. 3 and negative 4 is negative 12. So combine like terms here, and you get x squared minus x minus 12. Everybody with me? Okay, we have a quadratic, guys. So generally, when you have a quadratic, you move everything to one side and then factor it. So I'm just going to move everything to the left. So I'm going to subtract x squared, add x, and add 12. So over here, I'm going to subtract x squared, add x, and add 12. So on the right, it's just me. I like x squareds to be positive, so 90% of the time they're on the left-hand side positive, but it doesn't matter. I just like everything on the left. So over here, everything cancels out. What happens with x squared and negative x squared on the left-hand side? Okay, so negative 4x and x is negative 3x plus 7 equals 0. This no longer is a quadratic. This just means I don't have 2 answers anymore. I have how many? 1. So what would I do? Solve it. Subtract 7. So negative 3x equals negative 7. Divide by negative 3, and you guys get x equals 7 over 3. Now I understand that is a fraction. I understand some of you are thinking, I am not plugging a fraction back in to see if it works. Okay, I don't think that's the best idea. But at the very least, with a rational, what do you have to make sure that the answer you get does not do? Not that the x can be 0. The denominator can equal 0. You've got to plug, at least, the very least, plug your value into your denominator and make sure it does not make the denominator 0. On the review that I worked out, I worked this whole thing out with 7/3, so you can see. It's not pretty. It's not the easiest thing in the world, but you can do it. But you guys should check. Even though it's a fraction, you should go back and check your answer. Just get a common denominator. We all can do that. All right, scoot along. Yeah, sure. All right, what do we notice here? There's 3. All right, we need to get a common denominator. So what's the first thing you should do in trying to find the common denominator? Yeah, we need to break down the x squared minus 9. This would be x plus 3 and x minus 3. So now we've got to get a common denominator with all of them. My common denominator would be x plus 3, x minus 3. So I see that the first fraction has the x minus 3. What is it missing? So if I multiply the bottom by x plus 3, then I multiply the top by x plus 3. In the second fraction, I have the x plus 3. It's missing the x minus 3, so I multiply the top by x minus 3. The third fraction has both of them, so I don't have to worry about it. Now that you guys have created the equivalency, do you see all 3 denominators are the same? You don't have to look at them anymore to solve. So now it just becomes a FOILing problem. We're going to distribute the 6, so I have 6x plus 18. Notice this is a plus here, so I got a big plus. If it was a minus, you'd have to distribute a negative. But now FOIL. X times x is x squared. X times negative 3 is minus 3x. Negative 2 and x is minus 2x. Negative 2 and a negative 3 is plus 6. And I have equals 36. We've done problems like these a million times, guys. Put it in standard form. So you have an x squared. Anything else have an x squared? No. So I have 6x minus 3x. Right? I have 6x minus 3x is 3x. Minus 2x gives me just 1x. And then 18 plus 6. 24, God bless you, equals 36. What's my last step? Subtract that 36. Move it over. So you guys have x squared plus x minus 12 equals 0. Do we know how to factor that? What are factors of negative 12? That multiply to give me negative 12, but add to give me a positive 1. Good. X plus 4, x minus 3. So my 2x values are x equals negative 4 and x equals 3. What do I need to do with those two? Plug them in. Where is the most important place to plug them back in? The denominator. If I plug in a positive 3, guys, what happens to one of the denominators? So does this one work? No. This is the only answer that we can use. Just because you get 2 answers doesn't mean they always work. You've got to go back and check. No solution is a real possibility. You guys might have that. All right, the next part of your test is going to involve inequalities, linear and nonlinear. Linear means your x is to the first power. Okay, with a linear inequality, you have 3 parts to your answer. You have your inequality statement, you have your graph, and you have your interval notation. They all go together. So on an inequality, the first thing you should do is look at the inequality sign itself. What kind of a dot am I going to have on my number line? Why is it open? Because there's no line underneath. It's not or equal to. So on my number that I find, what is the notation going to be, a parenthesis or a bracket? It's going to be parenthesis. The reason it's a parenthesis is because it's not included. So now we're just going to solve this like we normally would. We're going to move all of our x's to the left and keep our numbers on the right. When you have inequalities, you want your x's to be on the left-hand side. So I'm going to take this negative 7 and distribute it. We get 5x minus 7x minus 7 less than negative 9. Combine anything you can. So 5x minus 7x is negative 2x minus 7 less than negative 9. Move that 7 over, so plus 7. We get negative 2x less than negative 2. What is the last step here? Divide by what? When you divide by a negative number, guys, what happens to your inequality sign? It flips. So this actually says x is greater than or equal to 1. Negative divided by a negative is a positive. Anytime you multiply or divide by a negative number, the inequality sign switches. So there's the first part of your answer. Now the second part of your answer is your graph. Okay, I put a number line on the test. You just have to put the numbers. I need to see 0 as a reference point and then whatever critical point you get. So what kind of a dot do I have at 1? Open. And then since my inequality sign, my x is on the left, I can just make a little arrow and it tells me which way to color. So which way do I color? To the right. Now you can check every single one of these. Every inequality you do, you can check. Plug in 0. The way that I have my answer graph, should 0 work? No. When you guys plug in 0 here, the answer is you're correct.
Is on the quiz, is it going to give us the graph?
Yes.
And then we just like fill it in?
Yep. You just have to put like the 0 and whatever and the open circle, that sort of thing. Yeah. Now your interval notation. We read from left to right. So you start on the left-hand side and you tell me where you see values, where the shading starts and when it stops. So if I start from the left-hand side and I go to the right, where does my shading start? At 1, and it goes to what? Infinity. What's going to go on both of those? Parentheses, because that number is not included. You're always going to have a parenthesis on infinity or negative. And then you have, depending upon if it's or equal to, then it's a bracket on the number. If it's just an open circle, then it's a parenthesis. All 3 of those parts, though, go with your answer. So now, I look at this one. Before I start anything, I'm going to give myself a little heads up. What kind of a dot? Close. So that means on the number that I find, I'm going to have what? A bracket. So just treat this like you normally would any equation. We're going to get numbers to the right, x's to the left. So I have 8 times 1 is 8, minus 32x, greater than or equal to 60. Subtract 8. Negative 32x, less than or equal to 52. Okay, now what? What happens when you divide or multiply by a negative number? You flip the inequality sign. You can simplify 52 over 32. If you divide top and bottom by 4, you get 13 over negative 8. So there's part number 1 to your answer. Part number 2 is your graph. So I need to see 0, and I need to see negative 13 over 8. What kind of a dot do I have at negative 13/8? It is closed. Good. And which way do I shade? To the left. And again, plug in 0. With the way that I have my graph, my inequality graph, should 0 work? No. So if we're reading from left to right, negative infinities on the left-hand side, positive infinities on the right, where does my graphing, where does my shading start? Negative infinity, and it goes all the way up to what? Negative 13 over 8. What goes on? Perfect. Good. You always read your graph left to right. Where does the coloring start? Where does it stop? Yes, sir.
I'm confused with the brackets and the parentheses.
If you have your inequality sign has the or equal to underneath it, it's a closed circle, which means it includes that value, so you put a bracket on the number. Over here, see how it was open? There's like no or equal to underneath. Yeah. So that was the open circle there, which means parenthesis here. Yep. Yeah, good question. All right, look at 15. This is still a linear inequality. There's a lot going on, but I know it's linear because nothing is higher than x to the first power. So look at your inequality sign. What kind of a dot are you going to have? Closed, and that means you're going to have a bracket. So now just treat this like you would any other equation. We're going to distribute the negative 6, so negative 12x. Negative 6 and negative 1 is plus 6. Then I have minus 7. What's 1/3 times 9x? 3x, good. What's 1/3 times 12?
4.
Plus 4, good, minus 8. Now simplify before you move stuff. I have negative 12x. 6 minus 7 is negative 1. Then I have 3x. 4 minus 8 is negative 4. Now we want to move x's to the left and numbers to the right. With our inequalities, you always want to do that. So I'm going to subtract 3x from both sides. I'm going to add 1. So I end up with negative 15x. My 1's cancel. Greater than or equal to 3x is cancel. Negative 4 and 1 is negative 3. Now I'm going to divide both sides by what number? Negative 15. Guys, if you divide by a negative, what happens to that inequality? It flips. Guys, a negative divided by a negative is a... So this becomes 1/5. Good. So now we're going to graph. I have 0. 1/5 is bigger than 0. What kind of a dot do you have at 1/5? It is closed. And which way are we going to color?
Left.
To the left. Again, if I plug in 0 here, with the way that I have my inequality graph, should it work?
Yes.
Yes. So your interval notation, reading your graph from left to right. Where does my coloring start? Negative infinity, and it stops where? At 1/5. Perfect. Good job, good job. I was doing good. Okay. Last bit. All right, this one is a little different. Why is this a tiny bit different?
It's a fraction.
Okay, there's a fraction, but where is the x? It's in the middle. This is one of those and problems. All right, notice you're going to have an open dot on this side, and you're going to have a closed dot on this side. That means you're going to have a parenthesis and a bracket. It's an and problem because the x is in the middle of your inequality. These are actually, excuse me, easier because it tells you where you're going to color. Where is x? In the middle. Where are you going to color?
1 through 5.
In the middle. Well, not yet 1 through 5, but I know what you're saying. So we want to get x by itself. So we have to undo everything that's happening to x. So in the middle here, we're dividing by 2. What's the opposite of dividing by 2?
Multiply by 2.
So you need to multiply every piece of your inequality by 2. So 2 times 1 is 2, and I have less than. My 2's here would cancel, so I have 3x minus 1. Less than or equal to 5 times 2 is?
10.
Uh-huh. Yeah.
Real quick question. So if it was like a negative, or like you got a...
Okay, good question. Say that was a negative 2 underneath. It's not. But if you were multiplying everything by negative 2, what would happen to the inequality signs?
Oh, the move flipper.
They would flip. Yep. At any time during your solving, if you multiply or divide by a negative number, you got to flip. So now I want to get rid of that 1. So I'm going to add 1 here. That means I have to do it over here, and I got to do it over here. So 2 plus 1 is 3. Less than 3x. This cancels. Less than or equal to 11. Last step would be to do what? Divide everything by 3. So I have 1 is less than x, less than or equal to 11 over 3. There's your inequality. So now I'm going to graph this. This is super easy to graph, guys. You already told me at the beginning what it's going to look like. Here's my 0, here's my 1, here's my 11/3. What kind of a circle do I have, or a dot, at 1? Why is it open? Because it's not included. What do I have at 11 over 3? Closed, because it is included. And where is my x? In the middle. So where am I going to color? There you go. And what can we always check? Always check 0. In this case, if I plug 0 in, should it work?
No.
No. So my interval notation here would be 1 to 11/3. Parenthesis on 1, bracket on 11/3. No matter how involved the problem gets algebraically, you still do the same thing. Yeah.
Would we get it wrong if we switched to 11/3 with the 1?
Yes. Because 11/3 is bigger than 1, right? You got to go left to right. So you read from left to right. Yeah.
If the 1 also had like the less than or equal to,
Mhm.
both be brackets?
Yep. Mm-hmm. All right, let's do these last two. If I don't get 20 finished before the bell rings, I'll do it. My planning period's next, so I'll do it and make sure I post it. These two are a little different because these are non-linear, right? It's not just x to the first power. So all you do in these kinds is you look at the inequality sign, and it tells you a lot about your problem. Then you just find critical points, and then we have to shade. If I look at this inequality sign, this says x squared minus 3x is less than or equal to. Less than. Remember I told you yesterday, less thans are and problems. That means you're going to be coloring in the middle. What kind of dots am I going to have? Closed. That means I'm going to have brackets. Now what we're doing, yeah.
The less than like only applies to non-linear ones?
No, it does. It's the same thing. But when you have linear, you have like x and then the number, so it'll tell you which direction it's facing. Right. So treat this like you would an equation. X squared minus 3x. If I move 18 over, negative 18 equals 0, right? So we're going to factor x minus 6, x plus 3. You guys agree? Okay. So x equals 6 and x equals negative 3. Those are the points that we're going to put on our graph. Negative 3, 0, and 6. Now, two ways you could do this. You didn't have to talk to yourself like you did at the beginning here. You could have just factored it, found your points, and said, okay, what kind of dots do I have now at negative 3? Close, because they're less than or equal to. And then 6. And then you can test points. You can test something to the left of negative 3. You can test something in between negative 3 and 6. And then test something higher than 6 to see where your solutions are true. But since at the beginning, we went and said this is a less than, that means we're going to color in the middle. So where can I shade? I already know where I can shade. In the middle here. Now, how can you check that?
0.
Plug in 0. If it works, you did it right. If it doesn't work, then it's the outsides. Yeah.
When it's like a non-linear, it's when something's squared.
Or cubed or something. Yep. Exponent is higher than 1. And then your interval notation, guys, both has brackets because it's both closed dots. In your non-linears, the only thing I'm looking for an answer is the number line and your interval notation. Non-linears, you just pretty much treat it like a factoring problem and then just test points. Like this last one. If I don't get through it, I will finish it on the video. This is non-linear because it's cubic. That just means we're going to have how many different critical points? 3. All right, so I know at each one of the critical points, I'm going to have what kind of a circle? It's going to be open. So that means I'm going to be using parentheses. But now let's just treat this like a normal factoring problem. I'm going to move the 3 over. So I have 2x cubed plus 3x squared minus 2x minus 3 equals 0. Can I group this? Yep, what can I take out of the first two? X squared, good. I'm left with 2x plus 3. What can I take out of the second two? Good, negative 1 becomes 2x plus 3. So I have 2x plus 3 just the one time. Hang on, don't pack up yet. And then x squared minus 1. Can I break down x squared minus 1? Yes, remember at the beginning you told me you had 3 answers, so get all 3 of them. This is plus 1 and minus 1. So your 3 points on your graph for x equals negative 3 over 2, x equals negative 1, and x equals positive 1. So the way that we graph this, guys, get your number line set up. In this case, you have 3 critical points. Negative 3 over 2, negative 1, and 1. What kind of dots do I have at all 3 of those? Open. And then we're going to test points to see which way that we shade. I'll do that right now in the video, and then I'll post it. Okay, so as you guys see, all right, when you have 3 critical points, this is where we have to test and see what values will make my equation true or my inequality true and what will make them false. So I always look at this as I'm going to split this up into sections. I have section 1 here, 2, 3, and 4. And what I'm going to do is I'm going to pick a number in each section, and then I'm going to plug it into my inequality and see if it's true or not. If it's true, that's where we shade. If it's not true, then we don't shade there. So if I'm going to pick something in section 1, I'm going to pick, say, the number -2. So I'm going to go back to my original inequality. So I'm going to try x equals -2. I have 2 times -2 cubed plus 3 times -2 squared minus 2 times -2 greater than 3. So when we evaluate this, guys, -2 cubed is -8 times 2 is -16. -2 squared is 4 times 3 is plus 12. Then I have plus -2 and -2 is 4. Is that greater than 3? -16 and 12 is -4 plus 4. So 0 greater than 3? No. So that means nothing in this section will make my inequality true. So now I'm going to go to this section between 3/2 and -3/2 and -1. Now, I know some of you are like, oh, I don't want to plug in fractions or anything like that. This can be difficult sometimes. I understand that, but you just need to find a number that's in between those two. So I'm going to say -5/4. Okay, that's in between -3/2 and -1. So I am going to try -5/4. So 2 times -5/4 cubed plus 3 times -5/4 squared minus 2 times -5/4. Is that greater than 3? So as we go through and evaluate here, I have 2 times, when I distribute this, I get -125 over 64. Here, I distribute this, I get, whoops, plus sign, plus 3 times, it's going to be 25 over 16. Here, a negative times a negative is a positive, so 2 times 5 is 10 over 4. Is that greater than 3? So simplify, 2 goes into 2 ones, 2 goes into 64 32 times. So I have -125 over 32. All right, so then I have plus 3 times 25 is going to be 75 over 16 plus 10 over 4. Is that greater than 3? I'm going to go ahead and change everything to 32s or 30 seconds. So I'm going to change this to 32. 75 times 2 is 150. I'm going to change this to 32. So 10 times 8 is 80. So -125 and 150 is +125 over 32 plus 80 over 32. Is that greater than 3? Guys, I can already tell right now that 125 plus 80 divided by 32 is bigger than 3. So I know that this area right here works. So now I'm going to plug in 0 because that's the easiest thing in the world to do. So we're going to try here with x equals 0. If I plug in 0 here and here and here, is 0 greater than 3? No. So nothing in here is going to work. So now I'm going to try something bigger than 1. So let's try 2. I'm going to try where x equals 2. Does this satisfy my equation? Or my inequality? So 2 times 2 cubed plus 3 times 2 squared minus 2 times 2, is that greater than 3? So 2 cubed is 8, 8 times 2 is 16. 2 squared is 4, 4 times 3 is 12. -2 and +2 gives me -4, is that greater than 3? Guys, I can already tell when I add 16 and 12 and subtract 4, it's going to be greater than 3. So I know that, yes, stuff over here works. So your interval notation would be from -3/2 to -1, union 1 to infinity. Anytime you have an inequality that is cubed, you're going to have an interval notation that looks something like this. You're going to have a piece that works here and a piece that works there. So make sure you guys are on top of that.